All right, everybody, welcome back. We're going to continue learning about systems of equations, and this time just learning another algebraic technique for solving systems. With this technique, of course, we'll start with pictures, just like we did with the animal problems in solving by substitution, only this time we're going to learn a different technique, solving by elimination. Let's get started. Be prepared to pause the video to think about some of these problems from time to time. So let's say yesterday I go to my favorite burger shop and I purchase this set of stuff. I buy 2 cheeseburgers and 2 sets of fries, and it cost me $19.30. And then today I go back to the same burger shop, and this time I purchase 5 cheeseburgers and 2 fries, and it costs $38.80. Do you have enough information from what I gave you to be able to figure out how much cheeseburgers and fries cost? Pause the video, think about it, and come back in a moment. Okay, now that you're back, one thing that you might have noticed is that the difference between yesterday's burger purchases and today's burger purchases came down to basically 3 cheeseburgers. So for example, there's 2 cheeseburgers, same as these 2 cheeseburgers here. There's 2 fries, same of those 2 fries there. So the cheeseburgers were the only thing different. So if I subtract 38.80 minus 19.30, that's the cost of the 3 cheeseburgers, because that's the difference between the 2 purchases. So I'll do 38.80 minus 19.30, and I did that with a calculator, and that came out to $19.50. So from that information, let me undo the pen here, we know that 3 cheeseburgers cost $19.50. And so you could take $19.50 and divide it by 3 and figure out the cost of 1 cheeseburger. So if we divide that by 3, 1 cheeseburger costs $6.50. And then from that information, it's pretty straightforward to figure out how much like the French fries cost. So you could just plug the $6.50 back into the original situation. $6.50 times 2 would be $13. $19.30 minus the $13 is $6.30. So therefore each French fry costs $3.15. So I solved that by basically subtracting the 2 equations, and then by subtracting the 2 equations and knowing that the difference was just 3 cheeseburgers, I could therefore eliminate the fries from that difference. So let's take a look at the next situation here, kind of keeping that in mind. So yesterday I went to a smoothie shop, love smoothies, and I bought 4 cherry smoothies and 3 kiwi smoothies, and it cost $30.85. Next day I went back and I bought 2 cherry smoothies and 1 kiwi smoothie, and it cost me $13.45. So do I have enough information to figure out how much the cherry and kiwi smoothies cost from this information? Pause again, see if you can figure it out. Okay, and now that you're back, let's try to reason through this. So in this situation, the difference between those 2 prices is not as straightforward as it was before. In the previous situation, if we just subtracted the 2 purchases, we only had cheeseburgers. But this time, if we subtract the 2 purchases, we still have 2 cherry smoothies and 2 kiwi smoothies. But one thing I noticed is that I could potentially double this purchase, and it gives me an easy path to elimination. So let's say instead of 2 cherry smoothies and 1 kiwi smoothie, I go and do that purchase again. And so I get another cherry and another cherry and another kiwi, and that costs me another $13.45. Therefore, 4 cherries and 2 kiwis would cost, what's $13.45 times 2? That's $26.90. So if I take the difference of these 2 situations now, this is a little more straightforward. So here I've got 4 cherry smoothies and 4 cherry smoothies down here, and then 3 kiwi smoothies and 2 kiwi smoothies down here, and this is $30.85, and that's $26.90. So if I double this purchase, I get information that I can work with that would help me actually eliminate one. The difference between this purchase yesterday and then like double today's purchase here is 1 kiwi smoothie. And so if I figure out the difference in the price, I know how much 1 kiwi smoothie costs. So let's subtract 30.85 minus 26.90. And that is 3.95. So we know now that if we do 30.85 minus 26.90, we get 1 kiwi smoothie, and that's equivalent to $3.95. So from that information, I can just plug that into one of the other equations and figure out how much the cherry smoothies cost. So let's say I take the 3.95 and plug it in here. 390, I'd do 13.45 minus 3.95, 13.45 minus 3.95, and that's 9.50. So therefore, 2 cherry smoothies is 9.50. And therefore, if we cut that in half, 1 cherry smoothie would cost, let's see, not remembering my math effects very well, 4.75. So there you go. Cherry smoothies cost 4.75 and kiwi smoothies cost 3.95. So we figured in both those situations, we figured out how much one thing cost by subtracting the difference between two equations, and it let you eliminate one variable. We either eliminated the cherry smoothies or we eliminated the French fries. And then we could solve an equation basically in one variable. Solving systems of equations algebraically using elimination is a very similar technique. So let's undo our pen tools here and scroll down so we can see how this works algebraically. So elimination is a strategy that you can use to solve systems of equations algebraically. You want to look for easy ways that you could do substitution or elimination when you're solving systems generally. But it works off this basic principle. If A equals B and C equals D, then you can add A plus C and you can add B plus D, and you still have an equivalent equation. You're just adding things that are equal. Likewise, you can also subtract things that are equal and you still get an equal statement. So I could do A minus C and I could do B minus D, and I still have a true statement because A and B are equal and C and D are equal. Just like we solved with the picture problems, it just kind of frames it algebraically. So let's take a look, for example, at some of these algebraic situations that we can solve using elimination. Here's a situation here, 4x plus 8y equals 20, and negative 4x plus 2y equals negative 30. So this first side is equal to that side, this side is equal to this side. I can add these two equations in their total to each other, and it would actually eliminate one of the variables. Because if I look at 4x and I add negative 4x, I get 0. It eliminates x. So let's add the two equations together. We're going to add this side to each other, and we're going to add these to each other. And we still get a true statement, but it helps us eliminate a variable. Oh, pardon me. So 4x plus minus 4x is 0. We don't need to write it. 8y plus 2y is 10y. And that equals 20 plus negative 30, which is negative 10. Therefore, y must be negative 1, because negative 10 divided by 10 is negative 1. We're not done. We take this value for y and plug it into one of the original equations so that we can figure out what x is. So let's plug y into maybe that equation right there. So if we do negative 4x, this is where my handwriting starts getting bad, negative 4x plus 2 times negative 1, we get negative 30. Okay, 2 times negative 1 is negative 2. We're going to add 2 to both sides to balance that equation out and get rid of that loner, plus 2 plus 2. So now we know that negative 4x is equal to negative 28. And now, therefore, x must be positive 7, because negative 28 divided by negative 4 is positive 7. So the solution to this system of equations is y is negative 1, x is 7. That would be the place where those two lines cross, and you can plug it into Desmos to check your work. I'm going to skip that step here, but that would be the answer to the one place where those two lines cross, and the only xy pair that works in both of those equations. All right, let's go to number 6. Sorry, trying to turn off my drawing tool so I can scroll. There we go. Okay, so problem number 6. They're totally out of order. In this situation, 8x plus y equals negative 16. Negative 3x plus y is negative 5. Well, I notice the difference between these two equations is there's a difference in the numbers here, and whatever the difference is between 8x and negative 3x, the y is the same. So in this case, you kind of have a choice how you approach it. You could multiply this side times negative 1 and then add both equations together. I just kind of subtract the equations. So in the previous example, we could add them together because we had a 4x and a minus 4x that would cancel out. In this situation, I'll subtract because if I take y and then I subtract this y, it'll cancel those out. But then I have to remember I'm subtracting everything all the way across the equation. So 8x minus negative 3x. See how that works? We're subtracting minus 3x. 8x minus negative 3x is 11x. Y minus y is 0. It's gone. Negative 16 minus negative 5 is 11. Negative 11. So then x must be negative 1. So you kind of saw two techniques. If one variable is like the opposite of the other, you can just add them, and then that eliminates one variable. If you have a variable that's the same from one problem to another, you can subtract, but make sure you subtract everything. You're finding the difference between both complete equations. So you can play around with whatever technique works for you. And then if x, of course, is negative 1, we have to plug it back into the original equation to figure out what the y is. We're not done there. So we'll plug it into the first one, 8x. 8 times negative 1 is negative 8, plus y equals negative 16. Add 8 to both sides, so y must be negative 8. There you go. That's the complete solution, the only xy pair that works in both equations. Okay, one last example. This one's a little more challenging. So in this example, this kind of reminds me of the smoothie situation. We see that we have negative 3x plus 7y equals negative 16, and negative 9x plus 5y equals positive 16. Well, there's nothing we can outright eliminate between those two, but I noticed that if I triple this equation, I basically end up in a situation where I can eliminate the x's really easily, but I have to triple like everything. It's kind of like tripling your purchase, you know, your whole purchase. So if I rewrite that but triple everything, I think I can eliminate the x's pretty handily. So let's change that equation. Negative 3x times 3 is negative 9x. 7y times 3 is plus 21y. And then negative 16 times 3 is negative 48. Now, if you're not favoring doing like subtracting all of this stuff from this stuff, one suggestion would be let's just multiply this whole equation times negative 1, and then you can add them, and it kind of saves you that mental effort of having to subtract everything. So I'm going to rewrite this, but multiplying everything by negative 1. So negative 9x times negative 1 would be 9x. Plus 21y times negative 1 would be negative 21y. And then negative 48 times negative 1 is positive 48. I'm going to keep this equation the same. This is kind of my control equation there. So this is negative 9x plus 5y equals 16. And now I'm in a good place. I can add both of those equations together and it will eliminate the x's completely, and then I'll just be able to solve the equation for y. So negative 9x plus 9x is 0, so the x's are gone. 5y plus negative 21y is negative 16y. And then 16 plus 48 is, I don't know, I think it's 64. So it is 64. All right, perfect. And then I'll divide both sides by -16. And so y is equal to -4. These drawing tools are a little bit slow, but that's okay. All right, so y is -4. So you take that -4 and plug it back into one of the original equations to find out what x is. So we could plug it into maybe this one here. So -9x. See, 5 times -4 is -20. Equals 16. I'm starting to have trouble with the drawing tools catching up. I'll add 20 to both sides, so -9x equals 36. And 36 divided by -9x is, or divided by -9 is -4. So x, as it turns out, is also -4. So the only xy pair that works in both situations is -4, -4. For your assignment, I'm going to refer you to some Khan Academy problems. So I'm going to go ahead and turn off the drawing tools here. Okay. I selected 2 sets of Khan Academy problems. There's systems of equations with elimination, the easy version, and systems of equations, the harder version. The easy version of systems of equations with elimination would be this one here. And in most of these situations, you can just add the 2 sets of equations together and it will automatically eliminate one of the variables, either by adding or subtracting. So it's like a really straightforward version of elimination. And then the ones with the challenge, you may find that you have to kind of massage the equations a little bit first by multiplying one of the equations by something before you can do the elimination. So it's great practice. Don't be afraid to use the hints. As you can see down here, I use the hints all the time just to make sure I understand their technique. So feel free to go through that. But let me know if you have any questions, and go back to the picture problems if you find yourself struggling with the basics of how it works. So have a great day.